I'm going to zoom in and we are live. Welcome to this live stream. Welcome to those of us on Twitter, Twitch, and YouTube. I have got the team here behind Nouns Vortex, which is part of the ZK private voting prop house round that's going on right about now. So we got Curry Rasul and Lev, and we will get started in just a minute. Right after this intro. All right. GM, Curry Rasul and Lavachka. Lev, GM, how are you?
GM everyone. GM Panda, well.
GM. Rasul, yeah.
Hey, everyone.
Great to have you two here. This is here just kind of a live conversation. You all are competing in this prop house round for nouns. We met in a Telegram group and kind of been keeping in touch with you over this process and wanted to really give a platform for you to talk about your solution, which is this Nouns Vortex, and also to really kind of get into your roots as builders, how you got into Ethereum, how you got into crypto, those sorts of things, for just kind of a free flow and live conversation. As always, is not no financial advice here. Absolutely not. I own Lil Nouns tokens. I own a lot of other tokens in the Nouns ecosystem, but we're not giving any financial advice. I encourage you, in fact, not to buy any crypto tokens. Just don't buy them. That's the advice if you need advice. But we're here. This is just kind of entertainment, interesting, and want to get to know these builders. So, all right, let's get started. Nouns Vortex. How did y'all name this? How did you come up with the name?
Oh, I do not remember exactly, but we had few different ideas. Actually, first of all, it's related to we want something related to pool or whirlwind or actually maybe Tornado Cash is the best name, but we want it to be second best in that sense. And we are also Team Mizu, which means water in Japanese. And so it was about maybe whirlpools, but we decided it doesn't sound too well, so we gone with Vortex.
What was the name in Japanese for pool?
We are Team Mizu. Mizu. That means water in Japanese.
Oh, okay, yeah.
And that's actually a cool idea.
Right here, Mizu. This is your team.
Yeah.
Awesome. Okay, so let's kind of start at the beginning then. You guys are you're building this prototype for zero knowledge voting. It's highly kind of mathematical, a lot of advanced cryptography. It's a very specialized thing. How did y'all get here? How did you meet? Let's start with Curry Rasul, maybe. How did you kind of get into crypto, and how did you get to this point where you're building this thing called Nouns Vortex?
Well, I got into crypto from my university years. It's from third year of my university. I studied decentralized systems, cryptographical protocols at university course. And after that, I was really interested in blockchains. So I was working as a Rust engineer, as a Rust software developer. But then I realized that one of the main things that is missing on blockchains I mean, by default, is like privacy. So all that data on blockchain is public, and I like it's common thought that we need privacy, and that's why I get interested in zero knowledge systems. Yeah, I started to learn that stuff. Yeah, it was really interesting for me. Yeah, because like the topic itself is super interesting, and like I understand that there are a lot of super smart people that like 100x times smarter than me, and I can learn from them. Yeah, something like that. And after that, like I participated in like many hackathons, contests, in many actually blockchain ecosystems, not only in Ethereum's. I participated at Tone ecosystem, at Near protocol ecosystem. Yeah, but of course, like we know that Ethereum is the main thing, is the main blockchain for Web3. We can say, yeah, and yeah, after like years of that, I got into like Ethereum ecosystem, yeah, something like that, and yeah.
Can you, sorry, I might have missed it in that, but can you say again exactly like how did you find Ethereum? Like what was your journey where now you say, of course we know Ethereum is the main thing. Like what got you to that place?
I mean, like Ethereum is the first blockchain with smart contracts. It's like the most popular blockchain. It's like the smartest people, I think, are in Ethereum. Yeah, so that ecosystem is like I don't know how to say that in English. Is attract me with it like principles, with it goals, with it achievements. Yeah, so I know like many developers. I was like at various conferences, not conference like meetups and other stuff where like I even found I met for example Roman Semyonov, and after like this, after I got familiar with this, after I knew these people, it like attracted me. Yeah, that's why. And right now, actually, I'm working at the Ethereum Foundation in privacy and scaling exploration team. So as Lev, as Lev too, he's working too. Yeah, we actually working on zero knowledge stuff. It's like high level explanation. Yeah, like that.
I love that.
Yeah, I'm sorry. Maybe it makes sense to point out that currently Russell's developing the spam protection mechanism based on zero knowledge, which
Yeah.
is called RLN, rate limiting nullifier.
Yeah, I can talk about this as well. Yeah, so I started to work at privacy and scaling explorations team.
RLN.
R, just three letters. R, L, N, like rate limit nullifier. Yeah. So like before this team was called
Rate limit, rate. It's rate.
Rate, yeah.
Rate.
Rate is funny too, by the way.
Okay. It's anti-spam protection, so it could be rate limit.
And actually, if you want to say exactly, it's not modifier but nullifier. It's like
Nullifier.
Yeah, nullifier is like yeah. So
Like
before this team was called like applied ZKP. So it like was a research team that develops like make research and development of zero knowledge protocols in Ethereum Foundation. And after the team like became very big, actually, not like very big as like Google or some stuff, but it's pretty big, and it was renamed to Privacy and Scaling Explorations. And I started to work there as a grantee from September. Yeah, and recently I joined as a full member. Yeah, I'm working there on like spam prevention protocol, like we said, like rate limit nullifier. Yeah.
I just love this website. And every time I go here, can you help me navigate to? Does your team have like a page here or?
Yeah, I send it to a private chat. Yeah, you can. Can you see it?
Yep. Got it.
Yeah, probably heard of like many projects. Like you can scroll up and you can find like projects like Macy, Sailor Font, there's ZKO Proof, for example, ZKVM. It's like
RLN was on the bottom right, I think.
Yeah.
If you want to find Russell, okay, maybe it doesn't show.
I'm not sure. Yeah, that I'm on the. I show. You can see me on the website. Because
yeah, but anyways,
we didn't update the members there.
Yeah, no problem.
Yeah.
Awesome. Okay, Lev, can we shift over to you for a minute?
Yeah, sure, but like it's actually a long and complicated story because I didn't consider myself Ethereum native, and I'm not actually a software engineer by my education. I'm a mathematician. So, and maybe to clarify, I'm not pronounced as Levochka, it's Levochka. But it might be hard for you to pronounce. So anyway, actually, I was pretty much strictly interested in mathematics until few years from now, maybe 2019, something like slightly before COVID. That was the point at which I decided to learn cryptography. Because I wanted to learn some field of mathematics that makes social impact, basically. Hold on.
That's interesting. Okay. So you said...
Yeah, so my goal for coming here was actually, at first it was strictly political. I do not want to go more into details, but it was like strictly political. So that's why I learned cryptography. And I was specifically interested in privacy for example, zero-knowledge proofs are used for both privacy and scaling. But actually, I have learned like how Monero works, how Zcash works. That's basically was my point of entrance into cryptography. And then through some word of mouth, I became involved in the ecosystem. And because most of the work is going in the Ethereum ecosystem, I naturally gravitated here. But initially, I was not Ethereum native. That's kind of fun. Yeah. But basically, I'm mostly interested in various like weird protocols ensuring privacy in some cases. And with PSE, I was working on adding multi-party computation in the voting system called Macy, which was suggested by Vitalik Buterin initially. Yeah, basically that's like a short version of my story. So, academic background, decided to learn cryptography, and eventually, like right now, I'm working in the ecosystem on some protocol design. Yeah, that's basically the idea. I can code. I know a bit of Solidity, a bit of Rust. Zero-knowledge languages I know quite well, I think. But mainly I'm a mathematician. So like design of protocols.
Okay. That's
Yeah,
fantastic.
that's like what I would like to say about my background.
I'm not sure if I should like correct this, but currently I'm not third year of university, but I just
No. That was the point when Russell got interested in
Oh yeah, okay.
cryptography, as far as I understand.
Yeah, okay.
Yeah. Okay. Cool. So the two of you end up getting together and connecting in sort of a Telegram chat. And I think I shared about this ZK contest, and you ended up making this proposal. So can
Yeah.
you talk us through sort of how did that come about? What did you guys think of this? I mean, yeah, let's kind of hear it.
Yeah, how did we come up with this, or like the details of what we are proposing? Just to clarify.
Yeah, let's talk about how you came up with it first, and then let's get into your solution.
Yeah. Okay. Russell, maybe you want to tell something? Or?
I don't know even how to start. Like I think we are friends with Lev. We just recently started to like recently became friends. I don't know if I can.
Yeah, it's actually really funny because okay, sorry.
Yeah, and like we were friends like before the contest. And currently we live like in the same city. We like visit each other. And actually we like were working on this proposal like when Lev like came to me, like we worked like
Yeah, we were talking about it in person actually for like few days straight,
we met in
discussing
person,
some.
and we were like we had discussion about votings and privacy in general even before these contests. Then when this contest like can you please Lev continue because
or that might
it
be
seems
enough.
I'm having a bit of I'm having a bit. I'm sorry, guys. I'm having a bit of trouble with Russell's voice. Is it a problem on my end?
do you hear me well?
Can anyone tell me? Okay, maybe it's a problem on my end.
Okay, yeah. When we find out that this like we found this contest, we decided to make a team and to create to think about some solution. Yeah, and that's how we started to work on Vortex, our protocol.
Okay, great. And then we can definitely go into sort of the details, kind of what your solution entails. And to kind of set that context, I mean, I'm going to try and make a diagram somehow, kind of at a very high level.
Okay.
But yeah, basically, how does it work?
Well, I don't know. Lev, can you speak, or should I like discuss the design? What do you think? Probably Lev have some like problems. Okay, I can start basically. We were thinking actually about there are like a lot of ways to build anonymous votings. Yeah, like simplest of them is like tornado cache semaphore style, where you just have like but it is like super simple, but at the same time it like doesn't fit well with requirements of this like contest. So do you hear me well?
Yeah, I can hear you great.
Yeah. So and Lev actually suggested that we should think of something in style of open like voting network. So it was like I can like explain in like abstract in high level explanation how it works. So it like every.
Hold on. Can we do it in this style? So this is my little noun right here.
Okay.
But let's assume he's like a noun. Anyway, this is my voting token. Let's assume there's a vote that I want to, vote in privately.
Yeah.
And so tell me, like, what's the user flow for me? And then at the end, it's my vote is cast privately.
Okay, so first you should like register into some like registry, and like it works like. Should I go like super deeply into the details or just high level explanation?
I would say more high level, like.
Okay, so basically you should first register, and while you like generating your secret keys and other stuff, you're making commitments to all this data and register, so it can support multi-sigs and other stuff. And you register after that, and there is some registry on a smart contract. Yeah, and after that, Lev, can you hear me?
Yeah, I'm back. Had some trouble with internet.
I can continue as well, but like as I said, like the main designer is Lev, so probably he will explain it better. Should I like continue, Lev, or you will do that?
I think you definitely should, because I do not even know at which point we are right now.
So we are.
Yeah, but maybe I could talk a bit about this. Maybe I could elaborate a bit on this multi-signatures and why do we even need the registration phase. So maybe I can explain a bit what is the issue here, if you want, like a small.
Why don't I go through it with?
I'm sorry.
How about this? Why don't you go through it at a high level, Curry, and then I'll come back over it and I'll go over all of it with you too, Lev.
Yeah,
okay,
sure.
Okay.
Sure.
So we have like registration. So it supports. I won't say how, but it supports like multi-signatures. So all the data you generate, it has like it has, like structure like supports multi-signatures and different ways to vote. For example, you can make pre-voting. Yeah, so a lot of details, but you make a commitment and register with it. Yeah, and after that you make like a simple vote. You just like call the function of smart contract. Yeah, and basically you are encrypting. Am I going too fast, or should I go slower? Probably, or everything's fine.
I think I understand it. So basically, tell me a little bit more about when I register into a registry. Does that mean I sign?
Yeah, you just. Yeah, sure. You sign a transaction and you actually adding yourself to a Merkle tree.
Me to a Merkle tree.
Yeah, Merkle tree is like common cryptographic like data structure. Yeah. So and after that you just vote. And you are basically make an encryption, so no one can see how you voted and how many votes you like gave. And you do that by like signing transaction again. But you can do that this from like different account, and basically you make a like membership proof, zero knowledge proof that you can vote and like your vote is correct, but you are not revealing any data. Yes, like that. And after like every person, every account votes, there are like some tally authorities that are that will decrypt like decrypt votes, and basically that's how we know basically that's how we know who has like, how can I say it? Like after tally authorities decrypt these votes, we can understand like, is the proposal accepted or no? Yeah, something like that.
I think I should clarify a bit. So they actually decrypt not individual votes, but the sum.
Yeah.
So the encryption is what is called homomorphic encryption. So we can add up the votes without decrypting them. And then, this result is decrypted by the tallying authorities. And so that's how the privacy of individual voters is preserved.
Yeah, like the final result is being decrypted. Yeah, and you can like find out the result. Yeah, and at this point, everything is fine? Should I clarify something probably? What do you think, Panda?
Okay, just give me a second. So basically, let me see if I understand it. So I'm a user, I'm a voter, so I'm going to show up to your smart contract and I'm going to say like, hey, register me. And then am I going to give you a new wallet that I want you to recognize me as?
I'm not understand what you mean. Like, you just like, what do you mean by new wallet?
Well, because when you said to vote, call the smart contract, sign transaction from a different account.
Yeah, it's like to like stay to remain privacy property. Like you don't want to show everybody that you are voting from your account. So
yeah,
like
okay.
Yeah, we hide not only the encryption value, but the account as well. So you can like just like internet cash. So first you putting the deposit and then you withdrawing the money from another account. Yeah, yeah. The scheme is the same actually here, pretty similar to that. Yeah.
Okay, maybe so to be clear, if you would only encrypt your vote, then we could still understand that you. So first of all, this is not the normal flow, because normally you will, what we expect will happen, that there will be some community relayers to which you basically send your proof and then post it on chain. We expect it to work this way. It is even more efficient because they can do it in batches, and that's more efficient than doing it one by one. But theoretically, if say relayers decide to turn off or censor you, you could just use any account, maybe unbounded from, not linked to your main account, and you could cast a vote from there. So this is like, but typically it will be relayers who post this data on chain. I hope this makes sense.
Yeah, we're gonna have to go simpler, but I'm generally following you. I'm just want to make sure I have everything right.
Yeah. So please ask the questions, like if anything is like not clear. Yes.
Yeah. So we have this. Okay. Maybe can I maybe go a bit go into a bit of in-depth explanation, but maybe it will clarify something. So you actually have two techniques. One technique allows to hide the value of the votes, but doesn't allow to hide the source of the vote. So you know whether a person voted or not. This is like encryption. And another technique is similar to Tornado Cache or Semaphore. It allows to hide who have voted, but who has voted, but it doesn't allow to hide the value of the vote. So if used by itself, it would mean that the nouner with many nouns would need to create multiple votes for individual nouns. This is really unpleasant. For example, if somebody has 30 nouns, they would need to create 30 vaults, and then cast them preferably in some different times to make sure that it's not linked. So this is really unpleasant. So we have decided to combine these two techniques, and not only we, for example, Defrost is using this similar idea. In this part, they are using the similar idea. So you use semaphore-like hiding or Tornado Cache-like hiding to hide the identity of the voter, and then you also use homomorphic encryption to hide the value. I hope this makes sense.
Exactly, that's how I wanted to say it.
Okay, I'm sorry. Yeah, and also about this registration phase, maybe it should be explained that what's the issue? So there are a lot of different trade-offs. For example, some people have hardware wallets. It is reasonable to keep noun in the hardware wallet because noun is quite it's reasonable to use hardware wallet for everything, basically. And then some people also use multi-signatures, for example, Gnosis Safe. And these multi-signatures might be some different smart contracts. And even then, there are some other smart contracts which operate autonomously, which are not multi-signatures, but something else completely. And so we wanted to have the system which kind of makes it decent for all these different kinds of nouners to vote. Makes it make the experience good. So what we ended up doing is we ended up with two options. One option is using native multisig. So for example, if you're using 3 of 5 multi-signature, then you can register 3 of 5 multi-signature. It will not be the same as the contract that you have started with, but you have an option to register 3 of 5 multi-signature natively in this system if you want. And then we also expect that there are some other kinds of smart contracts. For example, I'm not sure how exactly real nouns do vote, but I expect there are some smart contracts that are not multi-signatures. And for them, well, we have an option to enforce the vote on-chain. So basically, any account can post their vote in an encrypted form, and then relay it using our system. So that means that it will be clear that they have voted in some way, but it will not be. So this is a trade-off, but it will not be clear how they voted, and this works like for anything. So it works for hardware wallets, it works for any kinds of multi-signatures, any kinds of accounts that are able to that are able to interact with the system. It will be, it will work. Yeah, basically this.
Okay, can I ask some more kind of dumb general questions? So
Yeah.
you mentioned relayers a couple of times. Relayers. Can you explain, sort of like I'm really dumb, who are they? What purpose do they do?
It should be a community server. It should be some sort of community service. Basically, anyone can spin up a relayer. Relayer is basically just a bot which to which you can connect in some way. I don't know, via like IP, via some form on the site, or even via Telegram bot. I'm not sure how it will be done in practice. Possibly a few different ways are available. To which you can post this zero knowledge proof, and it will put it on chain. We need to somehow implement some sort of payment or compensation for spent gas. But basically, anyone can spin up such a relay. It is quite similar to what, yeah, sure.
Is it like a miner in Ethereum?
No. It's like a relay on Tornado Cash. So this is like, the main thing is you do not want to send a transaction from your own account. You do not want to send the vote from your own account, so because then everyone will know that you have voted, right?
Yep.
Yeah. So instead, you could, for example, use VPN or Tor, somehow hide your IP, and ask a friend, connect to this friend and ask them to put the zero knowledge proof on chain. So the Relayer is this sort of service which allows to put proofs on chain. And it serves to disintermediate your initial account or your accounts, which you do control, from the account that will deposit this zero knowledge proof. Okay. So I expect that like a few Nouners could run these relayers. It is quite simple. It should be quite simple. So I would expect it will be some sort of community service, basically.
Okay.
We can always incentivize them by making it so that it will need some work, but we can make it so you should also pay a bit to this relayer. But basically, at least to compensate for gas. But basically, yes, this is like anonymization service. And if you are really scared that they will like log your IP, then you could connect to them using like Tor or VPN. So yeah, but it will not leave any on-chain trace. That's what I mean.
Okay.
Anyways.
That makes sense. All right. The other thing I want to talk about is the tallying authorities here, kind of at the end.
That's an interesting thing. So what actually happens? So this homomorphic encryption technique, it requires you to encrypt your vote. Then votes are added up. Homomorphic just means that you can add them up without decrypting, by the way. That's literally the definition of homomorphic. So you add up these votes, and then you have encrypted it with some public key. And so you have this tallying authority who can decrypt the result and publish the result on chain. But there is an issue. So this tallying authority could also decrypt individual votes. So this is a central point of failure. So instead of doing this, what people typically do is they create some multi-party protocol, which is called threshold decryption. So basically you have N guys, and you need at least K guys to collude to decrypt individual votes. So, and there is a question, how do you choose these authorities and how do you choose this threshold? Do I make sense right now?
Absolutely.
Sure. There is a problem. You cannot really ensure that these people do not collude in some reasonable crypto-economic way. This is, by the way, why multi-party approaches to some other things. There are some approaches to various things in blockchains that are unsafe from the same standpoint. For example, you have this REN BTC, which is actually, I'm not going to say that it is like unsafe, but I'm going to say that I fail to see how it is crypto-economically secure. Or for example, you have this Rune or Tor chain, where if validators collude, they could like steal all the money, for example. But here, if these validators or tallying authorities would collude, they would be able to decrypt individual votes, and you could not do nothing. You could not do anything against them. So our approach is we use threshold k equal to n. Is we say that every tallying authority should be present, and if at least one of them is honest, then you have this, then everything is fine and privacy is not breached. So this is a bit different from like other approaches in the same like group. So for example, I think it's fine to talk about other proposals. There are few proposals that are using this threshold decryption technique, but they typically put threshold lesser than n, as far as we understand, or they do not talk about how they choose them. So we have like answer for this. We say that it should be strictly n of n, and that anyone should be able to join and be this tallying authority. So if you want to secure your own privacy, you can just join as a tallying authority, and you will secure your own privacy. Okay, does it make sense?
So hold on, let me make sure I'm getting this right. So
yeah,
for the voting to work, you need to have a certain number of tallying authorities, and your method requires the most amount of them to be honest. And if just one of them,
our method requires that if at least one of them is honest, then there are two things: this liveness and privacy, and these two things are in contraposition. So if liveness is big, then privacy is small. For example, so our privacy threshold is n of n. So we are privacy maxes right here. So our privacy is n of n, and our liveness is 1 of n, which means that if at least one of these authorities does not show up or like breaks the protocol, then the decryption will not work. That's the drawback. But privacy is maximal in the sense that if at least one of them is honest, then privacy is preserved. And we have the fallback scheme, which is played when liveness is broken. So basically, anyone can join as a tallying authority. They need to deposit some collateral. If they fail to show up, then this collateral is used to pay for gas for this fallback scheme. And if they all show up, then everything is fine. Does it make sense?
Yeah. So what happens if there's a vote, I use your product, and then at the end, someone doesn't, no one shows up and it's not live? Then what happens?
At least one of them doesn't show up and it's not live. Then the smart contract takes, so first of all, the vote is restarted. Like basically that's a failure. That's a failure. It takes a collateral of this tallying authority who didn't show up. And it pays for gas for another scheme, fallback scheme, which is much more tedious and is basically not using encryption and only using semaphore. This scheme requires more gas. It requires more work. It's unpleasant to deal with, but you can still do it. And we pay for this for the gas of this fallback scheme from the collateral of the authority which didn't show up. That's the main idea.
My vote still gets processed and will be cast. It just costs more during this stage to the DAO.
Oh, well, you will need to cast the vote again. Actually, this vote will be undecryptable because this authority decided to deny the service. So we could not decrypt your vote, and everybody will need to cast their votes again. But we will have this collateral to pay for gas. And it will not be economically rational for this authority to do this anyway, because they will lose at least 1 ether. According to our calculations, it will be maybe around 1 ether or something like this. Depending on the amount of voters, like the scale of the vote, but it's a significant amount of collateral.
Yeah.
We had a really weird idea that they basically need to put at least 1 noun as a collateral, but we decided to scrap that because we are not actually sure how much will nouns cost in the future. Maybe it will be lower or higher. Yeah, but basically they need to deposit some sort of collateral.
Yep. Okay. Can we say a little bit more about Merkle trees? That I generally know what a Merkle tree is, but I want to really get that down.
Yeah, sure. So that's actually very common for this. Okay, so Merkle tree is like a cryptographic accumulator. Basically, you have an array of values, and you can quickly prove that. So it has a root. Basically, how it works that you hash these values. You put them in the leaves of the tree, and then you hash them. So in each vertex, you have a hash of 2 of its children vertices. Child vertices, yeah. And so you hash it until you get one initial vertex, which is a root. And this Merkle root, so now you can create proofs against this root to show that, for example, some concrete element, like, for example, second element, or let's say third element is equal to something. So it's used as a cryptographic accumulator. So the set of all voters are Merkelized, put in a Merkle tree, and then this root of this Merkle tree is sent as a public input to your proof. Zero knowledge proof, and inside of the zero knowledge proof, you use this short argument that some of the leaves is actually you. And now you prove some stuff about it, that you have the permission to vote, that your voting power is something, blah, blah, blah. So it's like just basically everywhere.
Okay.
Yeah, but that's actually quite an interesting thing. So if you're a bit, so anyone who knows Solidity or maybe some how gas in Ethereum works should at this point ask the question: how do you construct this Merkle root without computing a lot of stuff? How do you construct this root of all voters without paying a lot of gas? And so we expect that there will be some optimistic procedure, which we're currently discussing. There are few trade-offs. But there are also some other approaches. For example, I've seen some approach which extracts this Merkle key of Merkle tree from the state root of Ethereum itself. This is monstrosity from the standpoint of that's quite a big zero knowledge proof, but they say, well, okay, we have managed to do it. So that's rocket science version, but we just expect that we will do it optimistically and it will work. Yeah, because we're compared to other proposals, we are relatively low tech. So we expect that our stuff will work in browsers, will work on mobile phones, blah, blah, blah. It will not require a lot of compute.
And easily auditable, by the way.
Yeah, that's like thing is like, but yeah, compared to some other approaches, we are less rocket science in a sense.
You say you think it'll work on phones?
We think it will. We think it will. We are pretty much committed to I mean, Rasul could maybe correct me if I'm wrong, but I believe we are, well, I'm not just too familiar with the mobile phone platforms, but we only use very cryptographically friendly primitives. And so I would expect that it will work. Like if the cache works, it will work. Basically this.
Yeah.
But maybe I'm a bit wrong. But Rasul,
No,
do you know
you're
anything
right.
about?
You're right. Like we
Okay.
use like Snark. This actually the point why Merkle tree construction is expensive. It would be cheap if we don't use like Snark friendly primitives. But that's what the discussion. So we decided to use Snark friendly primitives to have like fast prover time to make
Yeah, so I mean, there is like one hash which is cheap in Ethereum, but it's really costly inside of Snarks. That's Kichak, which is like native hash for Ethereum virtual machine. But we use different hash, Poseidon, which is not native to Ethereum virtual machine, and so we have some troubles with constructing this Merkle root. Yeah, but inside of the Snark, hashing is fast. So this is like a trade-off. Now, some other guys decided to go to the different side of this trade-off. For example, like I'm not sure Defrost. I think. Yeah, I mean, some other guys have decided to go a different route in this specific trade-off. So we are like, we will construct this costly Merkle root, but then we will use only Snark-friendly primitives.
Have you been saying zero cache like Zcash?
What's the question?
Yeah, when you were saying, were you talking about zero cache, Zcash?
Yeah, I mean, I'm just saying that. I just say that zero knowledge proofs are, in terms of cryptographically friendly primitives, are typically computable on mobile. For example, things like Zcash have phone wallets, mobile phone wallets. And so I would expect, like, once again, that's not like certain for me because I'm not aware about specific limitations of mobile platforms. Like, that's totally not my specialty. But I would expect that it should be doable because we use really friendly primitives. And our circuits are expected to be like, I mean, 20 times smaller than competitors because when they use friendly primitive, and that's not like that's. I'm not like trying to put them down. Just saying that we are on the side of the trade-off, which is about fast zero knowledge proofs. That's why I would expect it to work on mobile phones.
Yeah. Okay. And so, yeah, tell me on that trade-off. You're on one side. Some of the other proposals are on another. What's the first side is like efficiency?
Efficiency inside of the proof versus efficiency inside of outside on chain.
Yeah.
So we think what we do is we are on the side which is efficiency inside of the proof, and then we use this optimistic on-chain scaling to also cover the on-chain efficiency. That's our idea. But there are also guys who are saying, well, we'll try really hard and we'll do on-chain primitives inside, on-chain friendly primitives inside of this zero-knowledge proofs. But we instead use optimistic scaling. And we really like it. That's like our main, I think, main innovation of our approach is like this optimistic scaling. I mean, there are optimistic rollups, of course, but we are doing something new with optimistic scaling.
Optimistic zero knowledge.
Yeah, optimistic zero knowledge. That's really funny, but it seems to. Yeah, that's me. Okay. So yeah, this trade-off is it actually contained in, I think, 2 places. It's contained in 2 places. No, we are efficiency inside of, yeah, we're here. So basically, there are 2 places. One is how do you construct this Merkle tree, and then do you use Ethereum native hash to check, or do you use zero knowledge proofs native hash like Poseidon? And then another thing is the signature. Do you use this signature system? Do you use like zero knowledge friendly signature system, or do you use Ethereum native signature system? And so
Hold on.
we have decided. Excuse me?
Yeah, so on the signature trade-off, on one end was kind of the Ethereum native, and what was on the other end?
Yeah, ECDSA is Ethereum native. Ethereum native is ECDSA on SEC P 256 K1, and I mean the native curve of Ethereum and ECDSA signature. And we will use Schnorr signature on Baby Jab curve, which is zero knowledge friendly. Yeah, so this trade-off is the following. It forces us to require the registration phase. And it also makes us a bit weaker in regard to hardware wallets, because hardware wallets do not work with Baby Jab at all. So they can, for example, sign ECDSA native to Ethereum, but they cannot sign this. So this is why we require this registration route. But we believe it's not too big of a deal, because well, other people will also need this registration round to work with multi-signatures or to work with other smart contracts. So we expect that it's not too big deal. But there are like approaches that are strictly on the other side. For example, I think the not sure. I think the frost is strictly on the other side of this trade-off, or maybe as a KR's one. I'm not exactly. Yeah.
Help me to understand these 2 axes on the trade-off. What's on this side for the signature trade-off?
Signature Baby Jab curve. Baby Jab. That's the creature from the Alice in the Wonderland. Yub. Jab. I'm not sure how it's pronounced. Jab, yeah. Baby Jab curve. And here that's SEC P. I will write it down for you. Ethereum native curve. This one.
That
Yeah, so so the trade-off is: do you use the native signature of Ethereum, or do you use something entirely different? And we use something entirely different. But that requires the additional registration round. But on the other hand, we think that smart contract wallets will all still require additional registration round anyway, so we do not care too much about it.
Yeah, like maybe in future when we'll have more like optimal proof generation, even for not snark friendly mechanism, we can switch, for example, to other schemes. Like, but
Yeah,
for
I mean,
now,
if
it's
for
very
some
inefficient.
reason, for some reason, some magical approach comes, it could be, I think, switched in place. But right now we are firmly on the side of like low tech, and in particular low. That means that low compute, low of chain dependencies. For example, we do not require this like monstrous computation to construct state root, construct Merkle root from the state root. Yeah, so that's basically what we do.
okay. All right. Can we switch to do something a little bit more fun? You guys have another 10, 20 minutes?
Yeah, sure.
Yeah.
All right. I want to do some kind of poster with you guys for Team Mizzou, for Vortex. So I want to start with going on to Unsplash here. And let's find like a good image that looks good that we can work with. Mizzou.
Find a lot of bottles of some sparkling water.
Let me know if some of these are kind of cool. Let me know if you'd like any of these.
Yeah, I think this is really cool.
We can try to generate something with.
Yeah, you could ask me Journey.
Even better. Oh, I love that. All right, we're gonna go.
I can ask that if you want, for example, or if you have like subscription, you can do it.
Boom, we got our Nouns AI playground.
Oh, great.
All right. So we want a Vortex, right? Vortex, Mizzou. Let's get started.
Sure.
Try again. Vortex used to provide private voting service.
I will suggest something in chat.
You have something?
Yes.
You can send pictures in chat.
Yeah, I suggest the following prompt.
All right.
Maybe nouners with noggles.
Oh.
Maybe even like.
Let's try it. Let's see what happens.
Yeah, this looks. Can they have pixel art nouners with noggles?
I don't think it understands nouners. Let's try forecasting their votes into.
I cannot draw noggles at least. Can
Well,
I
we can add-
draw noggles?
We can add the noggles later. I gotta just
Yeah,
start
sure. That's a great point, but it seems they do not also understand. It doesn't understand vortex. It seems maybe solar punk whirlpool or something. Maybe I should say whirlpool or into the heart of the storm.
Maybe let's see. Maybe we just stick here for now. It's not like some of these,
sure.
and then we play around in Figma. Yeah. Do any of these stick out here as a starting point for you guys?
Yeah, I think the one which is tagged Abyss was quite good. This one is minimalistic. Yeah, it's minimalistic and fun.
Oh yeah.
Maybe you should add noggles falling into this. I think we should like noggles falling into this or like whirling around the heart of the storm.
Okay. So I think the first thing I want to do is I got to get you two on this. And the name, you guys are Vortex, right? Or Mizzou.
Yeah, you could add my PFP. It's some sort of, if you can access it, you can add my PFP here.
Yeah, I definitely can.
It's some sort of like fringe niche NFT with some story, but not sure if it's appropriate to talk about here.
All right. Like that. And then got what should I call you two? What names do you want to use in this?
I mean,
my nickname Karasul.
Yeah, I think nicknames are fine.
You can use like Karasul.f too.
And
do you actually have it? Yeah, I mean, I think this works. This one works.
Right? Lovuchka?
Lovuchka F should be fine. Should be fine.
All right. Now, this is the tornado head noun. I don't know if you guys like this.
I like it. I'm not affiliated with Tornado, by the way. I support the cause, but like I'm not the developer of Tornado. Maybe it's a bit too bad because I'm not actually a developer for Tornado. But well,
are you showing something right now? Because like I cannot see it.
Oh shoot! I'm in my Figma. Thank you for saying that. Let me go back.
Mm-hmm.
Okay. Yeah. Here's what I've got.
Oh, great.
So I'm thinking we need some noggles somewhere. Which color noggles do y'all like? Why don't we grab a couple of these? Do any of these colors stick out to you?
I will try to. Okay. I like these ones. Yeah, three color, they're cool. Like, absolutely cannot be seen. Yeah, you probably need some noggles with border, or they will not be seen in the heart of the storm.
Okay, how about let's go smoke. That's much better. All right, so what should we do? Should we put a bunch of them kind of in the vortex?
Yeah, they are like falling into the vortex. I think it would be cool.
Okay. What else? What else should we do here? I feel like we need some color. Well, I don't know. That looks good. What else should we add? Do you guys want your PFPs, or should we do something with the tornado? What do you think?
I don't know if that fits well here. I mean, PFP, for example, my PFP. What do you think, Lev?
Not sure. Maybe we're also falling here.
Why don't we do, you guys want to do noun PFPs?
Well,
'Cause it gets like models.
I'd like to. I'm not sure. It's like, yeah, maybe we should. Could be nice.
Yeah, I think so. Do you guys like any of the particular heads, or which ones? We could just do a random one. We could do any of these.
I think you can use my PFP and put noggles on it. I think it would be reasonable.
Okay. Your PFP from
Can you repeat?
No.
You've got to send me that PFP.
Do you have access to this picture? I'll find it for you.
Yeah.
I'll find it for you.
Curry, Razul, how do you want to be in here? Do you want to be? Do you want to make up a new one, or do you want to use your current profile?
Let me think. Let's generate a new one because like I like to switch my avatars often, so I'll probably yeah.
Do you like any of these? Do you want to look at the types?
Can you try one more?
Yeah.
Okay.
We've got a sun. We've got a whale.
I like the lowest one on the right side with like a crown. It's fun.
King. All right. So let's go.
It's funny.
Yeah, crown's popular. All right. Here's a bunch. Let me know which of these
you can pick like random. You can pick the like first one or on the second line, first one with purple glasses. Yeah, that one is interesting too.
Nice. All right. You're in here. And Lev, I see you just sent me one. Fantastic. Let me grab that. All right. Okay.
Yeah, now slap a noggles on this, and that's me in my nouns contributor mode.
Okay, you want to do RGB noggles?
Yeah, I think I want noggles on this guy. Or maybe it's someone. Yeah, something like this.
That's actually very cool.
Yeah, that's me. That's actually me. Look at this. It's me.
Like them small so they fit like right over
Yeah,
your
I like
eyes?
it a bit better, a bit bigger. I think it has slightly too close. Yeah, that's definitely good. Definitely good.
Yeah, but
Perfect. Absolutely perfect.
that's an upgrade for your PHP Java.
Yeah,
All right,
yeah.
now,
Maybe we
where
should
do
make.
you want to be? You want to be out here?
No, I'm like falling here with these guys. Yeah, maybe somewhere like. Yeah, sure.
And then Curry, where do you want to be?
I mean, probably somewhere on the left side. If like left on the right side, I can be on the left side.
Okay, I'm just gonna trim you up here. Okay, did you say you wanted to be on the left or the right?
Yeah, left, like symmetric to left space.
No, I think your name's got to be on the bottom. Oh, I know what I'll do. Okay. Boom. Boom. All right, how does that look, Dave? Oh, okay. I've got a new idea. Tell me if you think you don't like this. All right. What do you think?
That's very cool.
Yeah, it looks nice.
Should I put your names over your thing? Let's see.
I'm not sure.
Probably inside.
I'm not really a designer, but yeah, maybe it should.
Probably inside
Yes.
of the glasses, like above my head, and
It will not work. It will not work. It will
be too small.
small. Or not sure. Maybe it will work fine. Not exactly sure.
Yeah. Cool. as I'm kind of finishing up on this, do you guys have anything else you want to share or chat about? Anything you feel like we missed or you want to spend more time on?
Well, maybe I just wanted to talk that it was quite surprising for me how the DAO can actually operate, because like I had some, I would say, fairly skeptical expectations about the whole DAO thing, because I expected to be eventually captured by sort of centralizing forces, like, and I feel that Nouns DAO is not that way. It's quite decentralized at this point. Like, for example, like the first thing that I asked was, what is your Discord server? And you are like, we're like, we don't have one Discord server. We have a lot of Discord servers because we have a lot of communities. And that's like something which speaks a lot about the whole decentralization thing, for me at least. Like, it's a positive thing. Yeah, maybe this. So with all these discussions about private voting, about rage quit, like it feels like you are trying to
Shoot, it sounds like you're kind of breaking up there, but you were saying.
I would say sufficient.
Can you say that?
I'm just saying that trying. I didn't understand what. Maybe my internet is lagging.
Yeah, it's very lagging. It's very lagging.
Hey, maybe. Well, I will send a text message, like my final text message.
Okay.
Yeah, I'm actually also agree with Lev. So it's like very interesting to participate in that. So kind of great experience to speak with other teams, with smart people. Yeah.
Have you all talked to? I know you spoke on the Little Nouns space. Have you talked to other voters directly? Have there been Nouns voters who've talked to you and asked questions and given you feedback?
I know only one guy. I'm not like super like we're not like close friends. He just works in privacy and scaling exploration team also. I don't know even his like full name, probably Adrian. Yeah, and he asked me about a lot about our design and yeah, but I don't remember that we talked with other Nouns holders.
Well,
so that was actually even surprising that we got like that many votes because like our design, like honestly, really good, but we didn't expect that we like got too many so many votes without like actually being friends with us, like Nouns holders.
Well, we were approached by a lot in the Sankar, but I think everyone was in some form. But there are also a lot of people who we do not even know voting for us, and it feels very like empowering, I would say.
Yeah, I'm just looking here. So there's still 5 more days to vote. And this round is going to do 70,000 USDC to the top 3 teams. Right now, y'all are in 3rd place.
Yeah.
You know, one advantage I know, or one thing that was interesting, is you guys submitted really early. I think you were one of the first, if not the first, proposals to submit. Is that right?
The first. It was the first. Like actually the first.
And in terms of your vote, you've gotten a wide range of support from really serious voters. I mean, Nounders they're the founders of the project, who are heavily invested in its success, track it carefully. A lot of technical people. I think 7 or 8 of the 10 Nounders are technical folks. Personae Labs, they've done Hey a Noun. So they're a team that's been funded by this DAO, very well respected. Elad is part of the Verbs, right? He's a resident for the DAO. Noun 12 is a huge voter. You got some real heavyweights who voted for you. Seneca, a Nounder, Noun 40, big time.
Yeah.
It's quite pleasant. It's not clear if we will finally reach the threshold, but I think we got a lot of support already. Like it's actually astounding amount of support, I would say.
Yeah. And maybe could you speak a little bit to kind of the talking to other teams and improving each other and kind of how that's played out?
Well, it was quite funny because we made like this. We were a bit on the edge about should we publish it early or should we were done with our design in few days, like few days of constant discussions. But after a few days, we were like done with the design, and we were asking ourselves whether we should put it on the put the proposal, or should we somehow wait with it a bit to see what other people are suggesting. And so is it lagging again? I'm not sure.
No, you're coming through great. I can hear you.
Yeah, okay. So well, we have decided to just put it on and put it on the prop house, and then just say that, well, guys, if you're using our technique, please acknowledge us. And it was quite fun because we were referred, for example, Anonymous is another approach, but they do use our scaling technique, which we believe is novel and very cool. And well, it's we think it's all good because well, if our design is good, then maybe everyone should use it. Yeah, so that's our thinking about it. So that's what I believe what we think. So maybe we have influenced other guys too, or helped to figure out some trade-offs. But yeah, that's. And we were approached by some guy, I'm not sure if he put the proposal or not, who explicitly said, like, I've had same idea. Someone called Neural Virus. I'm not sure if he put in a proposal or not. But, well, of course, everybody is welcome to use our techniques, especially optimistic pool, because we believe optimistic pool is maybe a good scaling mechanism, not only for nouns, but for the whole zero-knowledge proofs ecosystem in Ethereum. Yeah, so we have interacted a lot. We are friends with some people in other teams. For example, we discussed some stuff with JPEG, JPEG, the guy behind Anonymous. Yeah. Overall, very friendly atmosphere. But yeah, we were a bit scared putting our proposal first.
Maybe we can also it's like off topic, but about this poster. So maybe we can remove this like white glasses, like going to Vortex. I don't think that they fit well. What do you think? Yeah, and we can.
Maybe they should be on the. Do you think maybe they should? I don't know. I like these glasses, but okay.
You like
Well,
this? Oh, okay. We can just like.
I'm not sure. Honestly, I'm not sure. Maybe they should be in a more symmetric way, so they're not like falling but staring in the abyss. But I'm not sure. I'm really bad at design. So
More symmetric,
I
or
recommend design posters.
or in random places, for example, something like that. Yeah, that's cool.
Yeah, okay. I just maybe wanted to finish this by saying that stay weird, guys, stay decentralized, and it will be all fine. All be good. And also, if you're saying something, you're muted.
Oh yeah, I was saying, what do you like? Do you like this Tornado Cash green, or do you want me to go to a different color? I just kind of did that without asking you guys.
I really like this this font. It's cool.
I also like this color. This like fits well with dark background.
And for the noggles too, and the text.
Yeah.
Yeah. Okay. Cool. And we got everything spelled right here. Is this right? curryrasul.eth.
Yeah.
Awesome. And then Levachka. Is this spelled right?
Yeah. I will answer for him.
Okay. Awesome. Very cool. Well, we're going to watch this race quickly. Again, 5 more days. Y'all are in 3rd place. It's been great fun talking with both of you and kind of talking with you throughout this process. Thank you both for coming on.
Thanks a lot. You too. Thanks for invite. Lova, you are muted.
Yeah, I think he Lova, GN. Thanks again for coming
thanks
on.
a lot once again. Thanks a lot.
All right.